Hey guys, Ray from Love You RV. So earlier this summer I purchased myself a new 3000 watt inverter for the RV, and also mostly so that I can use it when I'm testing batteries and stuff like that. Anyway, I did a video where I went through all the specs and stuff and why I bought it, mainly because it was on sale for about $500. I didn't need to spend huge amounts for the very deluxe inverters for my needs, so I went with kind of a cheaper end brand. Anyway, it's from Canadian Tire in Canada here, Motomaster Eliminator. It's actually replacing a 1000 watt Motomaster Eliminator inverter that I've been using for 12 straight years now. So I was pretty happy with that. I thought I'd give the 3000 watt model a try. In this video, I'm going to show you where I installed it and ran the wiring. One reason I picked this one is it had hard wiring capabilities, so I can hardwire it to a transfer switch. So that everything in my RV will work off of it. So I'll show you where I threaded the wire through the RV and how I hooked it up in the transfer switch, and we'll do a little bit of testing of it and kind of discuss an issue with it to do with grounding. Anyway, let's get to it. Before we go any further, first up I just want to do a little bit of a warning here. Of course, working with electricity is dangerous, but even more so when you're working with 120 volt AC power. The following should actually be performed by a qualified RV technician or an electrician. When you do it yourself, like I'm going to do, you may void your RV warranty and maybe your insurance, so keep that in mind. This video is just for entertainment, educational purposes, and you should not take it as instructional. And before I get to showing you the hookups in real life, my battery bay where all my electrical is quite confusing because there's so much going on. I thought I'd go through this block diagram. So here we go. I got a 420 amp hour lithium battery bank that I'm going to connect the inverter to, the 3000 watt inverter. So we've got a couple cables going between them. I've used what they call 2-aught cable, very thick cable. It's capable of handling the amperage between those two, especially because I have quite a short run. I'll show you in a second how I figured that out using an online calculator. And then I have a 250 amp fuse in the positive line here. Also, I've run an 8-gauge wire from the inverter to the RV metal frame. They call it the chassis ground. And that's basically there to protect against electrical shock. Say the output AC energizes the case in some way, and if this wasn't here, you could touch that case and then touch the metal chassis and you could basically get shocked. There'd have to be some type of failure in here for that to happen, but this is just like an extra safety measure they use. So I ran a little wire to the chassis there. On the outputs here, there's a kind of a telephone type wire or Ethernet wire that I run through, and I mounted a remote display inside my RV. Also, I have from my old inverter, 1000 watt inverter, actually that's how I had hooked that up. I had hooked it up with specific boxes just for that. I didn't make it part of my RV AC distribution. When I installed that, I had dedicated boxes in the living room and the bedroom, and that's how I used that. So I still have those wires there, so I'm going to hook them up, basically just plug them into the outlets on the end of this inverter, and then I can utilize them. And then it does have its hard wire output, so that's where the transfer switch is going to come into play. I'm going to plug into that, and I'm going to weave that wire through my RV to the 30 amp transfer switch. Now, why do I need a transfer switch? Basically, you don't want the inverter output and the input from, say, a generator or the shore power connecting at the same time. Most times you'll harm the inverter. It'll either short out or disconnect. Most times it'll damage it. So what the transfer switch does is it automatically will transfer between the two. They'll disconnect the inverter from the shore power back and forth, and then send whichever power out to the RV AC distribution panel. That's the thing that has all your AC breakers on it. So anyway, that's the basic block diagram of it. So let's go see it in real life. Oh, one more thing, calculating the size of the cables for the DC side of the inverter between the battery and the inverter. This is what I used to calculate it. I had existing what they call 2/0 gauge cables for my old inverter, so I wanted to reuse those. I don't want to actually step up to a larger 4 gauge or anything. I'm not going to use the inverter to run my air conditioner or anything like that. I just want to use it for the highest draw will be my microwave. So I figure I would use a 250 amp fuse, so maximum load current will be 250 amps at 12 volts. The length of my conductor round trip is about 5 feet, so I put that in there. I listed the allowable voltage drop to be 1%, so that's quite low. And my batteries, the 4 lithium batteries I have, can output 150 amps each, so 600 is my battery maximum amps, and they call it a main branch. So I hit calculate on here, and I get 2/0 will be okay, and maximum rating 250 amps, so I should be good to go. Now, looking around different charts on the internet, you'll find a lot of variables to the max amps of wiring. There seems to be something called chassis wiring and power transmission wiring. From what I gathered, chassis wiring is when you just have a single conductor, whereas power transmission wiring is when wires are kind of bundled together. So when they're bundled together, the amp rating drops quite a bit because it's got to do with how fast the wire would overheat and be a problem. So I always look for the chassis wiring. Anyway, that's how I came up with my gauge there, and it seems to be working good. So I've installed the inverter in the same basic location that I had the 1000 watt inverter in. I had to move a few wiring things around to make room for such a big inverter, and then screwed it to the back wall there. As far as AC output goes, I have the same 2 plugs that I had for my 1000 watt inverter. This black one heads off, and it's in an armor coated waterproof cable because it kind of goes underneath the RV and then pops back up into the main living room. This orange wire goes in straight up into the bedroom and have outlets there. So that's how I was running the old inverter. I wasn't installing it into any of the electrical of the RV. I just had dedicated outlets, sort of glorified extension cords. So I'm going to keep those in place just because I can utilize those while we're on shore power. The transfer switch will switch over the main power, but I'll still have those plugs will still be active. One of them, this black wire in the living area, I always plug Anne's iMac computer into that. Then if the campground power goes off for any reason and her computer keeps going. And then up here I have installed the hardwire cable. Let's see if you can see it up there and right there. And screwed in some wires into the hardwire output. I've used an old 30 amp power cord. Decided to get a new power cord for my RV, so I took the old 30 amp power cable and cut off the ends, and what I've done is I've run that through the RV. So if we go over here, I ran it along the wall, and then I drilled a hole with a hole saw through the wood, and then used some flexible conduit just to protect it. So that's going to head off through my storage bay. I'll show you that in a moment. As far as the DC power, I used basically the same cabling. I had 2/0 cabling installed before. I'm probably only going to use this inverter. I probably won't maximize the 3000 watts in my my system. The max I'll use is sort of for like the microwave, and I want to run the Instapot and various appliances. Probably only around 2000 watts max. So what I've done is I've installed a 250 amp fuse right here to protect the inverter. In my battery bank I actually have a 300 amp fuse as well. Sorry for the baby in the background. And here is, I put in a switch because I want to be able to switch it one way and utilize the inverter in my system. but I want to also do some work with external batteries on a little test bed here. So if I want to switch it over and test some batteries or something like that, I've just left a couple hookups here so I can hook up a test battery when I'm testing, say, a lithium battery, testing its specs and stuff like that. Then I can utilize this inverter for a high load test. Anyway, so yeah, it's got some pretty thick wiring feeding the inverter. Normally it's going to have my bank in here, which has 4 Lion Energy lithium batteries in it, so lots of juice to power the inverter. There's also a terminal back in there with a nut on it that you're supposed to attach an 8-gauge wire and take it to the frame, which I've done up here. It's just an extra safety measure in case this case was ever to become hot. I believe that would cause it to be a short to the frame of the RV. Anyway, let's go and I'll show you how I've threaded the black wire there, the 30 amp cable, and then we'll go in and show you how I've hooked it to the transfer switch. Okay, so here's the other side of the front storage compartment wall where it comes out through that flexible conduit, and then I've just tacked it along the roof line there, over, and then it goes into this flexible conduit and through that little hole into my water heater compartment. So we'll go in there and show you where it's threaded through there. Next, it's coming through the water heater area. You can see where it comes out there. It's actually attached a loop here, and then through this flexible conduit. And we go over to furnace. Look in there, and you can see I've just strung a whole piece of that conduit, and then it goes through this little wall here and then behind the power center. So let me pull the power center out, and then I can show you the transfer switch, how it's all wired into that. Okay, so we'll give you a quick look how I've got it wired into my transfer switch. This is my distribution panel for the AC and DC. Of course, I have the power all turned off. And you can see these orange wires. So this orange wire is the feed, the main 30 amp feed coming in from the RV power cord that you plug into your normal campground pedestal. And then this orange feed coming out would go to the distribution panel for the AC. I just have it unhooked right now just to make it easier to get all this stuff out of there, because I'm going to take that transfer switch and I'll mount it further in the back there. It has a cover that goes on it. And then this black is my feed from my inverter. So it goes in and hooks up to the transfer switch. If you missed all that, I did a video on installing a transfer switch last year, so I can link back to that if you want to see. It's a TS-30 30 amp transfer switch from Go Power, and you can see all the blacks are together, the hots, and then the whites are all the neutrals, and then there's a ground bar here. So I've just attached it to the appropriate places in there. Got my green wire going to this ground bar, and then the whites connected to the whites and black to the black. So what happens is normally the inverter is hooked up through this transfer switch to provide power to the distribution panel for the RV. Then if I plug into shore power, this thing auto switches over to shore power, disconnects the inverter. There's a big relay in there, so it disconnects the inverter's hot and neutral wires and then switches over to the incoming hot and neutral wires. And that basically takes place automatically. I think there's a time delay setting you can do. I think I have like a 30-second or a minute time delay before that switches over. Anyway, that's how that's all hooked up, so we'll put her back in there and sew it up. So if that transfer switch wiring kind of confuses you, here's a diagram. Maybe I can explain it a little better. So here's your shore power comes in, and it connects down here on these two connections. The inverter comes in here and connects hot and neutral down here. And then this will switch back and forth automatically. There's a relay in there, and it'll switch over to these two contacts and off to the AC panel in your RV. So normally if you have the inverter on and no shore power, it'll be switched between those two and those, and then if you plug in your shore power, it'll automatically switch to the other two. So at no time can the inverter and the shore power be connected to each other. This one also has you can have your converter charger hooked up to it. I personally didn't do that myself. What it does is it disconnects the charger when you switch over to the inverter, because you don't want the inverter powering the charger, which is charging the batteries, which is powering the inverter, and you get a loop, and pretty soon you're going to drain your batteries. I personally I have my own, there's a dedicated breaker on my AC panel just for the converter charger, and I manually deal with that just because I have solar and all kinds of other things going on, so it's easier for me to do that rather than automatically doing it. Anyway, that's how that works. There also is, GoPower has a different model that is pre-wired, makes it a little easier for people to plug everything in. You know, you got a cord to plug in everything, the inverter and the converter and the shore power, all that sort of thing. I bought the cheaper end one that you kind of have to do yourself. Okay, let's have a look where I mounted the inverter's remote panel. It's in our, what they call the toilet room here. And previously I've put my battery monitor up there. I have solar disconnect switches in here, so it's a logical place to put the remote panel for the inverter, so it'll report what the voltage is. You can press this and it'll switch to the AC voltage there, output voltage. It'll show me the output wattage. It'll show me the temperature of the inverter, and also I can turn it on and off here. So that'll work out good for me. So next I want to discuss a few things about the output of this particular inverter. Well, first of all, it is a pure sine wave inverter. My oscilloscope to prove that. You can see there's a nice sine wave being produced. No problem there. Just let me show you a voltage check though. So let's just plug in a tester to the inverter output, and you can see I get a single orange light. On a properly wired house circuit, there should be two orange lights. So what this means, it's indicating what they call an open ground, which is completely normal for this inverter because they have what they call open ground, or what they call a floating neutral. It's not bonded to ground. Let's do a test here with my meter. So you can see across hot and neutral, I have 115 volts, which is good. That's what I was measuring, that sine wave. But if I go from neutral to ground, you can see 57 volts. If I go from ground to hot, 57 volts. So the ground is not what they call bonded to the neutral. It's basically a floating ground, kind of like the generators. But it also measures 60 volts from either of those to the ground pin there. So it's just the type of inverter it is. Let me go on to the computer and I can kind of explain it to you maybe. Okay, let's see if I can explain what's going on with the open ground on the inverter. If I look in the manual, the hardwire instructions, this inverter comes equipped with optional AC output hardwire connection to allow for direct connection to an off-grid electrical panel. So I think that's the key word there, off-grid electrical panel. If you have an electrical panel that is grid tied, it's going to have the neutral and the ground bonded together, If you were to hook this inverter up to it, you could short it out, I imagine. So that's why they're saying only an off-grid panel. I kind of did some searching around, and you can really go down a rabbit hole with this stuff, but this was the best exclamation I found for it here from Samlex America. What are the standards pertaining to inverters where none of the current carrying conductors is bonded to the chassis? And here we go here. UL standard for this type of inverters does not have a requirement for bonded neutral on the output of the inverters. As long as the installation requirement of grounding the chassis of the inverter has been accomplished, loads that are plugged in will have their chassis held at the same ground potential as the chassis of the inverter and the house or RV. So I do have that one little wire that's going to the chassis of my RV. The only difference is that the neutral slot of the receptacle has approximately 60 volts on it instead of the usual 0 volts, and that's what I'm measuring. The impact of this is minimal since parts of wiring and equipment that are connected to the neutral side of the circuit are required by safety standards to be treated as if they were at 120 volts AC, since there are many receptacles that are wired backwards or two-prong plugs that are not polarized. Therefore, a voltage of approximately 60 volts AC of the neutral slot is not accessible to the user, and any shock hazard presented is mitigated by the lack of access. The main safety agencies, CSA, UL, and ETL, have all approved inverters with this half voltage on the neutral scheme. So there you go. Don't go by what I'm saying here. If you're installing an inverter, refer to the manufacturer instructions of how to install it. There's quite a few different types. Some have their neutral and ground bonded. Some have what they call a floating neutral, and you can actually manually bond it, etc., etc. But I think in these cheaper inverters, they kind of go with this system, and being that this was on the much cheaper side, that's probably why that scheme is going on. But I feel pretty confident that there's going to be no problem in my RV with it. It's sort of like plugging in a lot of the floating neutral generators, like your standard Honda generator. When you plug it into your RV, it's basically doing the same thing. Here's power coming in from the campground pedestal, and you can see I have 2 orange lights, so that's all good. It's wired correctly. That's because the neutral and ground are bonded at the campground's main panel. So that's what we would expect from the campground. So let's do a test of the transfer switch functionality. Right now I'm plugged into shore power. You can see by the 2 lights there. I'm going to unplug shore power, and it should automatically switch over to my inverter that's powered on, and you should see it go to 1 light. And there we go, 1 light. Okay, so it switched over, microwave stayed on, clock stayed on, so it auto switched over and kept the power. I'll just do a quick test here of the inverter. Oops. Working good, running my microwave. So now I'm going to do the opposite. I'm going to plug the shore power in, and it should switch from inverter power to shore power. Now there'll be a little time delay because I have a surge protector on my shore power that has a time delay, and I think the actual transfer switch has a time delay. Anyway, I'll go plug in shore power and I'll time the delay. Okay, she's plugged in 12 seconds ago. There goes my surge protector. It came on, so it's sending power to the transfer switch. Now the transfer switch has a little bit of a time delay too. I think that's to protect your air conditioner from switching the power too quickly. There we go. Took a total of 40 seconds to get power, and switched over automatically, and my microwave is still working well, so nothing disconnected during that time. Well, there you go. That's the installation of my Motomaster inverter from Canadian Tire. I'll come back like I always do and give you kind of an update on how it's went. I'm going to use it this fall and winter down south when we're boondocking, and also you'll see it used in any tests I do if I need to use it as a load on some batteries or stuff like that. Anyway, till next time, Ray from Love You RV. Thanks for watching. Cheers, folks.